Okay, this is much, much better.
There we go. Good afternoon. How are you? I'm Brandon. I'm with the AFWERX team, helping make sure you guys get all set up correctly. Darren, you're our moderator for today, right?
I'll be moderating. Essentially, I'm going to be introducing, I'm going to have the people introduce themselves and then just get on with the presentations.
Excellent.
The order will be Peter first, and then Peter and Prescott. And then we'll have Aaron Burt. Then we'll have Dennis Hardwick. And then we're going to leave the best for last. We'll finish up with Keith. Hi, Keith. How you doing?
Nice to meet you, Darren.
So we need Aaron and Dennis. They are not in the waiting room, but hopefully they'll show up soon.
We can maybe pin them.
All right, so we just,
Keith, where are you located now?
I'm located in Indiana,
Okay.
but I'm representing the OSD Manufacturing Science and Technology program.
Great. I want to ping Dennis.
So that looks like Aaron was just in, so he's switching Zoom accounts. And Brandon, do you see the screen that's got a 3-minute timer on it?
I do. Is that, oh, that's
So
live. Nice.
When I remove that, you see the golf balls, right?
Yeah, it looks good. Yep.
Okay, so on the golf balls, we're going to pour in sugar to show a demonstration of what cryogenics does with the molecular structure.
Awesome.
And so that screen, I think you as the host can pin that video when Pete gets to it. And when he gets to the words of St. Lakes.
Orthorhombic.
When you hear the word orthorhombic, then trigger that video to be pinned, please. And then we're going to give a demonstration on it.
I will, orthorhombic?
Orthorhombic. Or like a rhombic.
Like a rhombus?
Yeah. Like a rhombus,
Yeah,
yep.
All right. Cool. That would be the first request of leading sessions for the last 20 years. So
right on. Can you try that now to pin that video and see if it works for all of us when you click on the pin video button?
Magic. Worked, right?
No, I don't see it. So maybe it's just showing on your screen.
So
there.
it should be default to speaker view on your computer. If you have clicked on gallery view, then it wouldn't spotlight.
Yeah, it's on speaker view now. So I think maybe what we have to do is trigger that with audio. So we'll maybe have to mute that and then turn the audio on.
There it is.
Oh, there it is. We got it now.
Nice.
Yeah.
Okay, so
cool. So you pinned that video and it did work, just so you know.
Yep, it works.
Thanks.
Cool. Good job.
Sorry, I actually pinned it versus spotlighted it. Zoom terminology. It's all right. We're good.
Oh, so is spotlight the correct term?
Spotlight's the correct one. That's okay. No worries.
Spotlight. Okay, thank you.
I was following your instructions spot on after Romulus something or other.
Right on. Learning something new here. Okay.
How are we doing time-wise?
She's still up. She's about to finish her speech, I think, in about 3 or 5 minutes.
Are you 5 minutes ahead or straight up the top?
All right, so we are just missing Dennis, right?
Prescott, do you have Dennis's email or can you ping him? Prescott, can you hear me?
Yes,
I
sir.
can hear
I'll
you, so
ping
you
him
must
right,
be able
I'll
to
ping
hear
him
me.
right now. Yes.
Okay. Oh yeah, you were muted. Aaron, how you doing?
Very well. How are you doing?
Okay, not bad. Not bad.
Good, good.
So you're going to talk about how cryogenic processing pivoted to Army artillery, huh?
Yep.
Thanks for joining in, Dr. Burt. It's good to see you since Boston. It's been a few months.
It has. You guys doing okay?
Yeah, hanging in there. We're in Steamboat, Colorado at the moment.
Oh, you guys are just playing around then.
So it actually goes to his voicemail, Duran, when I call his cell phone.
I'll be back in 20 seconds.
Okay. Peter, do you have any idea how many people have signed up for this? Do you know what the audience is going to be like, or you have no clue? Oh, you're muted. You're muted. So, Prescott, why don't you unmute that so we can hear him?
Sorry, go ahead.
No, I've not seen a number anywhere, Duran. I have no idea whatsoever.
It's a bit strange to talk to an audience. You have no idea who they are, how many of them are there.
Right? It is.
It's a new weird virtual reality we live in, huh?
Brandon, do you have any idea how many people have signed up for these things? How many people are going to be on this thing?
There's on average between 1,000 and 3,000 people watching the live stream so far. In the breakouts and workshops and panels that have been happening, there's been anywhere from 4 to I think 400 people show up.
Did you say 1,000 to 3,000?
Yes. On the main live stream on YouTube, where you can just sit back and relax. I don't know how many to expect to have here today.
Wow.
With this group, that is. I wish I did.
When she finishes, will you cut back to the main moderators on the desk for a 1 minute before it cuts to us, or are we straight on after her?
No, so when the host finishes, they announce this, and from YouTube and the website, people then click over here. So it's usually 30 seconds to 1 or 2 minutes before people show up.
Okay.
Does that mean we wait like a minute and then kick it off, or we go
Yep.
straight into it? Okay,
Yep.
got it.
So you'll cue Duran when to start then?
Yep, and even more so, YouTube has between a 30 and 90-second delay on it. So what you see on YouTube isn't necessarily what's actually going on too, and it's a little different. So it's not perfect, but we've done quite a few of these, and they work pretty well. So hopefully this one is too.
Nice.
Yeah, I checked out that box that Evelyn had posted in the comments, or I guess someone from the AFWERX team, about the streaming device you all are using, and it seems pretty cool.
Yeah, all the different technology it's been fun.
So Prescott, you've got the timer. Is that yours?
Yeah, exactly. So we'll just start it on the side, and then I'll remove that once it starts. I'm just going to sync it to Brandon, so that way we kind of have an idea of where people are at. Once Pete finishes the ball demonstration, then I'll put that back up. And if you guys want to check in with the timer, you can see, your individual segments, what's remaining. I guess we could do it that way.
And altogether,
If that helps. Otherwise, I'll just repeat.
altogether we have 25 minutes.
That's correct, yes. So I basically got like an interval timer, and then I just broke it down with the interval timer into each section of what's in the schedule there in the email.
And I'll put the overall 45 minutes on the shot clock here that you can see. You can always look over to my screen and see the timer of how much time we have left.
And what application do you use for that timer? That's pretty cool.
It's a TV studio software that just runs through Zoom in the background.
Nice. Okay. Very cool.
And is it 45 or 25?
Did you say
At
25?
25.
Oh, it's 25. Sorry.
25. Very good.
Panels are 25. Sorry. Workshops are 45. My bad.
No worries.
No problem, no problem.
We should be right on.
I know Aaron could fill the time if he needed to, but
Hey,
I can speak for,
you know me too lucky.
for 60 minutes anytime.
Keith, the scary part is I learned from Duran, so you're in double trouble here.
it's all right. I don't know if I've got 5 minutes or 4 minutes or 1 minute of meaningful contribution. So I'm just here to be a pretty face.
I'm doing a damn good job of it.
I don't know. I put on a tie.
You're doing better than me.
I haven't put the jacket on for 4 months. This is the first time wearing a jacket.
He asked me about that earlier. He's like, do we need a tie? I was like, no, absolutely not. No one will be wearing a tie. Now I feel like an idiot. Sorry.
Yeah, I didn't want to, let's not make Keith feel bad. But,
That's my fault. We were wanting to show up in ties, but I don't think there's enough time to tie the tie to match you now, Keith.
you look great with a tie, Keith, so don't let anybody give you a hard time. But it's
It's part of the uniform.
sure feels
You in
strange.
Michigan right now?
I'm in Indiana.
Oh, Indiana. Okay. Oh, that's right. You're at Naval Service Works Center, Crane. That's right.
I'm gonna send Dennis an email.
So he just sent a
might be
chat.
joining
He
right at the
just doesn't have
3 p.m.
video.
mark. He might be joining at the 3 p.m. mark because he did shoot me back a text message.
Oh, he did. Okay.
Yeah, he didn't say anything to say yes or no, he'll be on. He just said, can I call you back? It was one of those automated things when you hit, hey, I can't talk right now. So I assume that means he's on another conference call until 3. Oh, he says, I'm on, can you see me? So can you promote him, Brandon?
What is this Q&A session here? I see questions.
Got it. Yes.
All right.
I'm on.
Dennis should be here.
Yeah, Dennis is here. I can see his, yeah, there we go. He just doesn't have video.
And yes, Darren, there's in the Q&A
Yeah.
and chat, the audience has the ability to pipe up with questions that you can choose whether or not to ask the panelists if you so wish.
Guys, can you hear me now?
I hope 3,000 people do not ask questions. That's
I'll help you if they do.
Hi, Dennis. How you doing?
Pretty good. Can you hear me?
We can hear you.
All right. Yeah, I could see you guys, but I couldn't participate when I first zoomed in. So, but I'm good now.
Thanks for joining us, Dennis, and bringing the EWI perspective. We appreciate it.
You're welcome.
So in terms of what we're going to do is I'm going to introduce, I'm going to welcome people, introduce myself quickly, and then I'm going to ask each of you to introduce yourselves so they know who the panelists are. And then we're going to talk about the innovation where Peter and Prescott will talk about that. Prescott will be the last one to talk about it. And I think, Prescott, you're going to do a case study, right?
I'm just simply chiming in after Pete goes in his first founder's presentation and overview of cryo. I'm simply saying a factoid about, hey, that 300 below is, that 300 below is an AFWERX multiple silver recipient, and we won Innovation of the Year. Here's the details. So like in a minute, basically, and then we'll move right on to Dr. Burt. And then in the end, I'll wrap it up and say, if you'd like to donate or contribute an idea, you can go to metalupgrade.com and you can submit an idea in writing or via a mobile video. And then we'll recognize you, like you said, Duran, by sending them some peanut butter cups, and they can appear.
You're going to do that at the beginning then. Okay.
Yeah, I'll do that. I'll do that at the end, but I'll do the overview. Like after Pete goes to the overview, I'll say AFWERX, Silver, and Innovation. Yep.
Then I'm going to move over to Aaron to talk about the opportunities, and he's going to talk about what he's done with ARL.
And yeah, and the Army crossover. Yep.
At which point I'm going to talk about the Olympics. What's it called, by the way? What's the name of that?
Advanced Manufacturing Olympics with AFRSO, the Air Force Rapid Sustainment Office.
Advanced Manufacturing Olympics, right?
That's correct. Yes, with AFRSO.
Air Force Office of Scientific Research, right?
Yep.
And I'll bring in Dennis to talk about that because Dennis, you can talk about the work at EWI with additive manufacturing and how that.
That's right.
fits.
Yep.
Okay.
Yeah, we're looking at cryogenic cooling just to really increase our build rates, but also reduce residual stresses in builds. So,
Particularly the residual stresses, yeah. And then after that, we'll go to Keith.
And where I'll give a thoroughly non-material science overview of OSD, Mantech, and some of the technologies that are downstream of advancements in cryogenic metallurgy.
Nice.
Great.
That's what you wanted, right, Prescott?
Thanks, sir.
Very grateful. Thank you.
Sounds like you, Aaron, do you know Keith from previously? Have you guys met each other? Okay.
Yep.
I just sling mud at people randomly.
And I just take it randomly.
There you go.
So Dennis, you're still working with Lyft, right? I see you're still on.
I am. Yep, I'm still at 10%. Been waiting on, obviously, them to get new money so we can get new projects going, but they've been keeping me on. I'm kind of like Phil's, technical sort of developer on the side, when he's out developing these OTAs, and they've been mippering money through on, these congressional initiatives and things like that. I get involved and help write the work plans and get the
I was a pillar co-lead on the metal casting the first 5 years of Lyft, and that's where I first met Dennis years ago. Wonderful.
All right, gentlemen.
So are we going to show is the intent to show our video of who we are talking while we're talking, or do we want to, is that the intent during the whole, everybody's going to be live on video too?
Video on the whole time, and they just kicked us off from the main session, so we're gonna have some people joining us. We've got 12 people already watching, and so Darren, let's wait about 30 more seconds, and then we'll officially kick it off.
Okay.
If you would like, we can even kick it off with a little music.
You just give me the clue when to start. We don't need any music. We'll make our own music. We'll make our
Oh, is
own.
that, I could have, all right, that's good. All right, so we just jumped to 26 people. So I would say, Darren, let's get started. More people are going to be joining us along the way. Welcome to this. And Darren is our moderator. Please kick it off.
Okay, welcome everyone. Welcome to the session that we have here that is titled Improving at-Risk Military Metals to Save Lives and Win Wars. We got an exciting panel here for you, and my role is to moderate it. And my name is Gio Anapelian. I'm professor of material science and engineering and head the metal processing activities at University of California, Irvine. I want to ask our first participants, Peter Paulin, to say a few words and introduce yourself.
Hi, this is Pete Paulin. I'm CEO of 300 Below, located in Decatur, Illinois. We're a materials science company.
How about you, Prescott?
And also with Peter here with 300 Below.
Terrific. So these two gentlemen are going to talk about the innovation. After we finish the introduction, they're going to come first and talk about the innovation. Let's go next to Aaron Burt from Solvis Global.
Perfect, everybody. My name is Aaron Burt. I am co-founder and CEO of Solvis Global. We are a technology development, implementation, and commercialization company specializing in all things materials and manufacturing. So I'm excited to be part of this panel and talk about the impacts that cryo are having on the future of materials and manufacturing.
Thank you, Aaron. Well, Dennis, why don't you go next and introduce yourself?
Hi, I'm Dennis Harwig. I'm a research professor at Ohio State University Welding Engineering Lab, and I have business appointments with the Edison Welding Institute, also known as EWI, and the Lightweight Innovations Institute for Tomorrow. My specialty is really advanced arc welding and robotic directed energy deposition additive manufacturing, really large-scale structures.
Great, Dennis. Thank you. And we're leaving the best for last. Keith, why don't you introduce yourself?
Good afternoon. I am Keith DeVries. I am with the Office of Secretary of Defense Manufacturing Technology Office. I serve as the program manager for the Manufacturing Science and Technology program, where we're interested in those nascent applications and cross-cutting joint service manufacturing challenges that ensure that no American warfighter is in a fair fight. We want to keep the advantage every day and into the future.
Very good. Thank you, Keith. Well, let's get the conversation started. Obviously, metals have been around a long time and will be around for many, many more years, and they play an amazing and huge role in the defense of our nation. And we're here to talk about processing of metals to bring out the best performance in them. So let's talk about the innovation that 300 and below has come up with. So Peter, why don't you take it from here and tell us what this is all about?
Thanks, Duran, and thank you all for joining us under the U.S. Air Force umbrella of lightweighting and stronger materials. 300 Below is an AFWERX recipient of multiple SIVRs and a materials science company. Let's take a brief trip down the rabbit hole of molecular science. You're about to view an astounding value proposition. It really is. Deep cryogenic thermal processing creates a permanent, homogeneous change to the molecular structure when treated at deep cryogenic temperatures. How good is it? Well, let's say you called your stockbroker on your retirement account and said, I've got $20. I'd like you to turn that $20 into $300 in 72 hours. And that essentially is what happens. For about 20% cost, deep cryogenic processing can improve materials as much as 300% in longer life. It's an astounding value proposition. Homogeneous change to the molecular structure all the way through. What we do is extend the quench. You know those old John Wayne movies, right? You can remember the scene with the guy with the horseshoe and the fire, and he's pounding on it to make it malleable and reshape it. And then what does he do? He quenches it in water. That water quench doesn't just magically stop at 72 degrees. What actually happens as a function of physics is it moves all the way down to absolute zero. Well, we're most of the way there at 300 below. We use liquid nitrogen from the atmosphere. And so let's take 1 minute and take a look at deep cryogenic processing on a technical aspect. Orthorhombic, fancy word for ortho meaning movement, rhombic meaning the shape. That orthorhombic conversion due to thermomechanical compression precipitates fine eta carbides in ferritic structures. And that precipitation fills all of the voids in between the molecular structure, creating a coherent structure for the molecular structure itself that's permanent and irreversible. So what you're actually watching is the addition of some sugar into some golf balls here, but it fills those voids. That illustrates steel as a crystalline structure and the change to a permanent, coherent structure. It also happens in aluminum by perfecting defects and dislocations. So what are the benefits then as a result? Over 500 PhD level papers say huge, right? We've now focused previously on tool steels, and the purpose of being here now is to expose new technology to the building materials for the US Air Force. And after processing over 20 million pounds, we're expanding into building materials and polymers. Recently, we found that polytetrafluoroethylene, that stuff in your pans in the kitchen, improves by 50%. Nylon, like tennis racket strings, improves by 300%.
Can you give me a glass of
Fire
water?
suppression sprinklers
Mine's
in
right beside the
building
coffee pot.
systems also go 400% less corrosion. Deep cryogenic processing of materials results in numerous benefits, and let's take a moment to look at those. 300% increases in abrasion resistance. 2, stress relief and stabilization. Fancy words, but what do they really mean to you watching this? Well, everybody's done this. We're going to impart some stress in a simple piece of paper by folding it. I just put compressive stresses on the inside and expansive tensile stresses on the outside. And you know that when you tear that, it now tears directly along that line. Cryogenic processing through thermomechanical compression and expansion helps to normalize that structure. This has huge implications for aircraft structures like wing spars that have flex fatigue issues or skins from cycle fatigue from pressurization. So it normalizes, stabilizes that structure so that it's a more uniform structure as a result. There's also a 30% increase in heat transmissivity. What's that mean? Well, if you're creating a coherence of structure, the heat can transmit more rapidly. And in things like engines, motors, all types of heat, heat is the enemy of metals. And so we want to extract that heat as rapidly as possible in most cases. So then the last one is scale. What can we do scale-wise? Well, we've treated the 27,000-pound canopy die for the F-22 Raptor for the US Air Force. So you can imagine that we could treat an Abrams tank at this point. Additive manufactured 316 stainless steel was proven to have a 30% increase in hardness from DCT. The process is totally green, coming from nitrogen in the air. You're about to meet 3 preeminent PhDs who will illuminate the possibilities further for buildings, aircraft, ordnance for the US Air Force. Although it's a perceived alchemy, it's been turned into a pure science by 300 below. Back to you, Duran.
And also, I would like to add, it's really cool to work with you, Dad, because thanks to his long work and the decades that he's put into it, yeah, I've served as a prior Marine Corps officer, and I've seen a lot of metals obviously being used in our military for our warfighters. We're very fortunate to have received multiple AFWERX SBIRs to help explore and experiment and research this technology further. Last year, we won Innovation of the Year in Manufacturing Technology. So that was a really big win, not just for us, but especially for the Air Force and ultimately for the warfighter. And as you'll see here in just a moment with Dr. Burt, we've partnered with Solvus Global to take our technology and pair it so that we can now help the Army with things like artillery. So back to you, Duran.
Terrific, terrific. Thank you very much, Peter and Prescott, for that. And as a educator in the field of material science, I can tell you that we know a lot about what happens to materials when we increase the temperature. We have phase diagrams galore, but when it comes to the control and manipulation of the defect structures and the residual stresses, when you lower the temperature, that's where the innovation really exists and huge opportunity. So Aaron, why don't you take it from here, from Solvus Global, and tell us about what you're doing with this technology with the Army.
Absolutely. So thanks for the introduction, and it's really good to see engineering and science kind of explained in practical manners. That's really good. Thank you, Pete and Prescott, for sharing some of that. So I want to talk about what we're doing in the world of large cal extended range munitions and systems for the Army. So there's a growing need across the whole DoD, but in particular for the Army, to develop next generation platforms that have greater propellant energy, that have greater life, and that are overall increased accuracy and increased range. And that's the whole ERCA program. As part of that, there's a number of burning needs there. One is alternative coating systems that can replace the existing chrome technology. Chrome, if you've been part of any of the studies for the last 50 years, is not great for the environment. Hexavalent chrome is being banned in a number of different areas. And so there's a real need for not just something to replace, but also something to improve. And as part of that, there's also a growing need to be able to recover and reclaim many of the artillery cannons that are in use. Why? Because they're expensive and have incredibly long lead times for fabrication, because there's a lot of engineering and science that even goes into the cannon tubes themselves. And so what we're doing in partnership with the Army Research Labs, in partnership with 300 Below, as well as actually X-Tech Search SBIR program, is to develop basically an all-encompassing set of coating technologies, as well as repair and replacement technologies for the next generation of cannon systems. So the coatings are designed to have a higher temperature performance, be able to handle the higher stresses and chemical and corrosion impacts from next generation propellants. And on the side of the repair and the restoration, we're developing a partnership and an approach alongside of 300 Below to evaluate how we can improve to the point that Pete just made, the heat transfer capability of these cannons, the hardness and wear resistance of these cannons, as well as the scalability of this types of repair and restoration. So today there are a number of different areas where you can experience a failure or a decommissioning of cannon tubes. So that might be something to do with firing events. It might be due to production events. But what we're doing is taking and evaluating each of these different areas, each of the different types of defects that might be found. And we're using a novel process known as cold sprays. This is a solid state additive manufacturing process where we can spray metal or ceramic metallic blended materials onto the surface, both OD and ID, so the outer diameter along the external surface, as well as the inner diameter, the interior surface, to repair and restore these different regions depending on the specific type of failure that's occurring. And in conjunction with 300 Below, what we're doing is evaluating for these different repairs, how can we improve the life of the barrel after it has been decommissioned? How can we take it and bring it back to life and then have it actually last even longer than it did before because of a combination of novel coating protection as well as novel processing that can improve the material performance and material properties of the coating and possibly even, and this is the exciting part for us to evaluate further, the bare steel itself. So we're very excited to continue this partnership and collaboration across not just the Army, but also the tri-services at large. So I think that's my time. Thank you so much. Be happy to talk about this more after Q&A or offline. You can find me at aaron.bird@solvisglobal.com.
Very good. Thank you, Aaron. I should point out also that just yesterday, we received the news that the University of California, Irvine, where I'm at, and 300 and Below have been invited to participate in the Advanced Manufacturing Olympics that AFWERX is sponsoring. And we're going to be looking at additive manufacturing of aluminum cerium alloys with cryogenic treatment. So we're very excited about this opportunity. And this would be a good segue to ask Dennis Harwick, who also has a foot at the Edison Welding Institute, where they do a great deal of additive manufacturing, to possibly talk about some of these opportunities as well. Dennis, why don't you take it from here?
Thank you, Duran. Can you hear me?
We can.
Okay. So like Duran said, I'm leading a range of graduate research and applied research projects for industry on metal directed energy deposition additive manufacturing, or we just call it DED. This includes several large naval programs to mature robotic DED for shipbuilding and establish the qualification standards to accelerate transition and implementation. My focus is really large-scale structure builds used in defense and shipbuilding, heavy manufacturing, and energy and chemical. Metal DED is used to add features to structure and build unique structures like rocket nozzles. Metal DED is also being used to replace long lead castings, and in some case provides builds with better properties. At EWI, we've transformed almost all our robot systems into DED systems by using Power Mill software. Here we created a digital twin for 6 to 11 axis systems. Our largest system is 11 axis multi-process gantry that has a build capacity of 10 feet by 15 feet by 20 feet. So getting into cryogenic cooling, process requirements for metal DED additive manufacturing specify maximum interpass temperatures for depositing beads. And if above the interpass temperature, the deposition process is suspended until the build is below the temperature requirements. DED processes are basically welding processes. They're laser, they're arc, they're electron beam using wire or blown powder type feedstocks. And they have high heat inputs and high deposition rates. So depending on the build thermal mass, the majority of the build rate and economics can be impacted by interpass temperature requirements. On a range of builds that we've made, we've seen our build rate be reduced by 80% of the process deposition rate, just spending time waiting for the part to cool between passes. So we've explored forced air cooling and water cooling, and they have some benefits, but they have a lot of limitations. So a more efficient approach is really using cryogenic cooling for interpass temperature control between deposits and or in situ directly behind the welding torch for cooling rate control. So we have a range of projects that are being launched to develop cryogenic cooling treatments for DED. Again, between deposits or in situ while we're depositing material. This technology has been found to offer maximum duty cycle and deposition rate, lower residual stresses and distortion, ability to use higher heat inputs and deposition rates, and is clean. It leaves no residuals on the build surface. So overall, we're really excited about this technology for providing higher ROIs on DED investments. And from initial calculations, it can provide a 2 to 3x return on investment compared to not using cryogenic cooling while doing builds.
Very good. Thank you, Dennis. Keith, why don't you take it from here and talk to us about your perspectives, particularly about the impact of this work for the Department of Defense.
Fantastic. Yes. I have to say, I am incredibly humbled to be included in this panel. Obviously, we have some preeminent experts in the field to speak about the whats and the wherefores of cryogenic cooling and its impact on the metallurgy. I, as a simple electronics engineer, am really a part of the panel as the user, the guy that comes along and takes the fantastic innovations and seeks places to plug that in to solve problems for our warfighters. And so as the OSD Mantech program, the cryogenic cooling and metallurgy benefits have wide-ranging potential influence. And honestly, we see this in a collaboration, as Dr. Burt was mentioning, with some of the work that's being done elsewhere in my portfolio in cold spray technologies. But beyond that, you know, the Navy has these large metal structures that we call ships and submarines. The Army has vast metal vehicles that also, you know, there are definite benefits, as Pete was discussing earlier, in making our tooling better. And now as the technology is advancing, you start looking at raw materials and applications. Where are we going to put our better metals? And so that's the function that the service Mantech offices. So there's an Air Force Mantech, Army, Navy, MDA, DLA, and then Office of Secretary of Defense has a role for joint applications. So in partnership with those entities across the services, we will be looking for the places where we can plug the innovation of stronger, longer life metals into solving the challenges of protecting our warfighters, giving them a better weapon in their hands, and taking the fight to the enemy. I understand that I'm using a lot of very broad platitudes because, again, an electronics engineer can get pretty mystified by the metallurgy. But I know that there's a ton of application potential, and I would rather leave it in the hands of the experts to talk about how that application really finds itself manifesting in how we do it. So I lean on the expertise across DoD R&D enterprise. So that's the scientists and engineers at an ARL for the Army, the Air Force Research Lab, or the Navy Warfare Centers to coordinate and collaborate to bring the great ideas to our attention. And we seek the mechanisms to invest in how do we manufacture using advanced materials. So in some cases that's a cold spray, some cases that's a cryogenic metal, sometimes it's both, right? So that's how we fit into the equation. We are excited to see how this technology is maturing, and really very humbled to be a part of the panel.
Thank you very much, Keith. If I could just chime in here for a second. You know, some of us define the field of material science and engineering as the science of being able to control and manipulate the defects in the materials. It's really the manipulation and the control of the defects, whether it's dislocations, vacancies. So it is really astounding to me when you think about the field, how much effort and energy has gone into studying what happens to materials and metals when you raise the temperature, but not as much as to what happens when you lower the temperature. I'll just give you one example about corrosion. You know, especially with materials that are used, corrosion is a very important attribute in addition to strength, ductility. And corrosion only occurs when you have an anode and a cathode and an electrolyte in the system. And an anode and a cathode can be easily produced when you have a stress razor, just like Peter showed that piece of paper with the stress that he applied. So cryogenic treatment actually reduces all of those, homogenizes it, and we're seeing tremendous increases in corrosion resistance. So there's a huge opportunity here. And I'm going to leave the last word to Prescott, who's got an announcement he wants to make.
Yeah, we welcome everybody's ideas on this panel, and we appreciate your attendance and participation. If you do have an idea of how we could apply the science of cryogenic processing to at-risk metals to improve military objects that are used by our warfighters, please take a look at the website I just posted. It's metalupgrade.com. You can submit your ideas on there, either as a short video or as a written idea submission. And we will make sure that the award winner gets at least a pack of Reese's peanut butter cups here. And in addition, I know that Duran will also feature your top winning idea at the upcoming ACRC meeting. So with the last minute, maybe you can share the impact of that. But essentially, I really just encourage people to get ideas out there, and those videos will pop up on that website. So if you submit a video, everyone can see it, and we can all share ideas about what's next for the warfighter and where we're going to go to make this impact in our military. And that's how collaboration and innovation is going to happen.
Nobody's got a monopoly on ideas, innovation, so we want to open this up to all of you, and please participate. And 300 and below sounds like a very cold process, but it's a very, very hot process. And I think I'd like to leave it with that and finish it with this. To the panelists, thank you very much for your time and effort. And Brandon, I think we're done, right, with our time.
Yep,
Absolutely.
we're done. If everybody wants to go back to AFWERXfusion.com, the show continues there. Thank you, panelists, and we'll see you later in the week. Have a good one. Thanks,
Thank
everybody.
you all. Take care.
Thank you.
All right.